All right, sounds good. Let me go ahead and share my screen and we'll get going.
Yep.
Awesome.
If I can find the right screen. Is this the one? Yep, there we go. All right. Good evening, everybody. And that's okay. This will have to do for now. I'm not sure why this doesn't want a full screen, but that's okay. So what we're going to do tonight is talk about enterprise cloud patterns, specifically aimed at Java developers. As some of you have already gathered, my name is Pratik Patel. I am a Java champion, and I do some other things as well. I dabble in some JavaScript, done some machine learning with Python as well. And of course, I try not to code Perl if I can help it nowadays. But nowadays, people make fun of YAML, but you know, whatever. Before I get started, I just wanted to have a couple of quick announcements for some new community initiatives that the JUG that I'm a part of, the Atlanta Java user group, is doing. The first one is the javacafe.com. This is a new community content portal that we currently have in beta, but anybody can go and register and publish their own content. In fact, my own personal website is on here also. So the idea is that we wanted to make it easy for people in the Java community, and anyone, to be honest with you, in the Java and cloud community, to be able to go and have a personalized website and publish content with the least amount of friction and without having to pay anything. So that's pretty cool. So we rolled that out. It's available now at the javacafe.com. You'll find that some people have already started to put content up there, and we hope that you will too. The other thing is that we also rolled out earlier this year Virtual JUG North America. And the idea is that while we're still in pandemic mode and even afterwards, we can share some of the nice JUG meetings that are going on across North America with our audience. And so every month a different JUG hosts it. I think the last one that hosted it was actually Garden State. And then we have Knoxville JUG hosting, quote unquote, hosting Virtual JUG soon. So anyways, getting back to our main presentation. What we want to talk about tonight, again, is enterprise cloud patterns. And this is the rough outline of the presentation. First, I want to spend a few minutes on philosophy, and then maybe do a quick cloud native review, and then jump into some patterns. This is the first time I'm giving this presentation. So if you have any feedback or something that you could see improved, or if you liked it, of course, please let me know or post it on, send me a DM on Twitter or whatever. And I can improve it once I get a chance to do it again. The actual content for this is a little bit different than what was posted on the Pittsburgh Java user group website. That is because I started to flesh this out about 2 weeks ago, and I ended up with about 40 or 50 pages of notes, and it was going to turn into about an 8-hour course. And of course, nobody wants to hear me present for the next 5, 6, 8 hours. So I've whittled it down to something which I feel that Java developers will get a lot of value out of in terms of understanding what you need to do as a Java developer or an architect to be successful on the cloud. And we won't be able to cover everything, so hopefully we'll be able to do something like this again as a follow-up in like a multi-part series. Okay, so let's start with some super basics before we get started and talk about the philosophy around cloud-based development. A lot of people call it cloud native, of course, which is fine. But for me, when I think about cloud native and cloud, it's the same thing. It's basically app development targeted at a specific type of platform, which is basically not your data center or an old PC sitting underneath your desk or whatever. And one of the main things I like to emphasize to people is that when we're building in a monolith, we don't really think of elasticity. We think of a set number of resources, and then when we need to scale up, or for that matter, scale down, we have to do a lot of work, especially infrastructure work, and sometimes work as app developers to either scale up or even scale down. But the important thing here is when we go to the cloud and we think of develop for the cloud in a cloud native way, we need to keep elasticity in mind. Everything has to be designed around elasticity. So when we think of what does elastic mean, it means that we're able to, again, scale up, scale down, but not just compute resources. Your entire architecture needs to be able to scale up or down as needed based on what you're building. Okay, so a lot of times when we think of elastic computing, we think in terms of horizontal scaling as opposed to vertical scaling. If you're not familiar with the difference between those two terms, when we're building out software, vertical scaling is basically something like, I'm going to go add more RAM and more CPU to this server, right? And that's called vertical scaling. Horizontal scaling is, I'm going to go add another server that has CPU and RAM, and that is how I will scale out this application. But again, I want to emphasize that when we think of cloud and we think of elastic architectures, it's not just the compute that has to be elastic. Your entire architecture should be elastic. That includes things like network, storage. If you're using services that are your own services or third-party services, are those services elastic? Can they grow as your application gets busier? And can they shrink when your application is less busy? Okay. Now, common question at this point is, well, why is there such an emphasis on your platform and your architecture being elastic when you go to the cloud? Well, there are a few basic tenets around this. There's the obvious one, which is cost. So when we think of the standard monolith type of application that you might be running in your own data center, you don't have elasticity. You have a fixed cost. You have 10 servers running your application, and that's basically it. You pay for them running all the time, and it's expensive, et cetera, because you may not be utilizing all 10 servers 100% all the time, right? Most applications don't. When we go to the cloud, we have the ability to start with X number of CPUs and X number of RAM, X amount of RAM, and then from there, we can scale up and go and add extra servers on demand or even automatically, especially if you're using something like Cloud Functions, to be able to do that horizontal scaling. But for me, I don't feel that that is the most important thing, even though a lot of people get stuck on the cost of elastic computing and cloud computing in general. I think the second two bullets are far more important, because if you think about how much it costs to hire a developer and to keep that developer productive and contributing to whatever you're building, the ability for a developer and a team of developers to adapt and be agile and make the most of what resources they have. When I say resources, I don't mean human resources, because I would never call humans resources, first of all. But when we think of the compute resources and the other infrastructure resources we have, how quickly can we adapt our application to the resources that are available to us? And can we be agile in terms of rolling out updates faster? And along with that comes security. If you're running in the monolith and you don't have a flexible elastic architecture, how do you apply security patches quickly so that you don't have problems? All right, everyone has heard of the recent issue, for example, with the pipeline going up and down the East Coast. Actually, I think it goes from Atlanta to Pittsburgh, which is kind of funny. But you get the idea, right? The more agile you are, the faster you can roll out security updates, but more importantly, the faster you can roll out application updates. And that brings us to our third point, which is time to market. Having the ability to adapt quickly and to be agile also allows us to get features out to our customers faster, i.e. it reduces our time to market, which if you ask people who are your business analysts, they will say that, hopefully they say that that's important to them and they want to get features out faster. Okay, so what I want to do next is just quickly touch on cloud native. I don't think I want to go through all of these slides in too much detail, because I want to spend more time on the actual enterprise cloud patterns that I want to show and demonstrate and give you some insight into. Okay, so I think pretty much everybody is aware of what cloud native means and what are some of the core tenets, but we'll just talk about the few of them very quickly, right? So at the very high level, when we think of cloud native architectures, We think of things being containerized for the purposes of isolation and replication, all those different types of things. And of course, say containerized, we're essentially referring to Docker, okay? And along with that, once we have these units of code running inside a Docker container, we can do dynamic orchestration. That means we can fire up multiple Kubernetes pods running our Docker containers and scale horizontally as we need to do that. Of course, there's a lot more to that than what I said, and we'll dive into some of those topics in a few minutes. And then, of course, one of the core tenets around microservices, around cloud native, is that it's microservices oriented. Now, you can do a monolith in the cloud, and there are actual patterns for doing monoliths in the cloud and being successful at that. So if you're thinking, oh, my app not really ready to be broken down into smaller chunks and into microservices, and there's a lot that we need to learn, that's fine. You can still be successful bringing your monolith to the cloud without having to totally decompose your application into smaller bits. You can use a lot of what's available on the cloud to still get some agility and to still get that horizontal scaling that you need, right? You won't go 100% of the way. You can't get all the benefits of it, but you can get some of it, even if you're not doing microservices. Okay, so we're going to skip ahead here and talk about enterprise cloud patterns, which is the primary topic that we want to dive into today. So there are a large number of these patterns. Last time I checked, I think there were like 30 or 35 of them. We don't have time to go through all of them, but what I've done is I've picked some of the ones which I think Java developers will be able to say, yes, that's something that's interesting to me because that's a challenge we're having right now, or we're going to tackle this in the next few months, or maybe you've already tackled it and it'll be a good review for you to get a better handle on if you've done this correctly, or if you're thinking about, or if you've thought about how you've done it and you've done that correctly, right? So in a lot of ways, the way that Java is presented in the cloud and manifest in the cloud as applications is no different than other types of programming platforms. A lot of people talk about JavaScript on the cloud, and of course Go on the cloud because of its lower utilization. But I often challenge people who say, well, Java is not really fit for the cloud, right? Especially for things like cloud functions or Lambdas. And I say, well, that's not necessarily the case anymore. Java is a modern programming language. All of you have probably been keeping up somewhat with, for example, Java 11 and the latest Java 16 releases with records and this and that, also all sorts of those new features which are coming into the language itself. But one thing a lot of people don't realize is that every time a new version of Java comes out, there are additional performance improvements, and newer versions of Java start up faster. Newer versions of Java use less RAM, for example, and there are frameworks coming out like Quarkus, which allow you to build applications in Java, which are very, very, very small in terms of footprint, i.e. CPU utilization and RAM utilization, and somewhat importantly, the startup time associated with how long does it take to spin up a Java app with limited resources, right? Because we have to remember when we're running on the cloud, even if we're running in a Kubernetes cluster, we don't have a huge number of resources like we would on our, MacBook Pro or whatever type of machine you use to develop on, or if you have some internal staging servers and stuff like that. Okay, so Java is performant on the cloud, and there are new things coming out, and there are old things that have been around for a while that help you make Java applications on the cloud be successful and work really well. Okay, all right. So now you're probably thinking, well, I already read the Gang of Four book. I already know all of the different design patterns. And one thing I like to tell folks when we're talking about cloud patterns is that you will recognize a lot of the stuff that we're about to talk about because you're like, I've done this in code before. I've built a facade. I've done a decorator. And the cloud patterns that we're going to talk about are extensions of those. But I think the important thing that as a developer, we need to realize is they're not at the code level or at the mod level. They're more at the systems or infrastructure level. So it requires a little bit more thinking from our end as Java developers to understand how we need to approach these different patterns, and that there's not a direct one-to-one corollary between something that you did at the code level in terms of a design pattern compared to how you do it at a systems level in a cloud type of environment. Okay, all right, so let's dive in and talk about some of the patterns, and let's discuss the 4 broad categories first. The 4 broad categories for cloud patterns are design and implementation, performance and scalability, data management, availability, and resiliency. Okay, so again, we're only going to cover the ones that Java devs will find most useful for migrating to the cloud. There's lots of other ones which are also useful for Java devs, but we want to try to wrap this up before 7 o'clock. So we're going to try to keep this a little bit more focused than going into all the different ones. So let's talk about the first one. The first one is known as the ambassador pattern. This is a pattern that is useful for legacy application transitioning. So what does that actually mean? Right. So let's switch to this view real quick, and let's actually look at what the ambassador pattern looks like. And bear with me just a second so that I can get this up, make sure it's working properly. All right, so we're going to do a quick set of drawings, and hopefully this, why does this not go away? Okay, we'll just move this to the corner, and then we'll talk about the ambassador pattern. All right, so the ambassador pattern, again, is for when you have a monolith or just some kind of legacy application. It doesn't actually even need to be a Java application. It can be any kind of application. And you want to start making it cloud aware and cloud native. How do you do this? It can be challenging, of course, when we do this. So let's draw a quick picture here, right? So let's say we have a client or some kind of external service that's calling into, or has been calling into, our legacy application, right? So here's our legacy app down here. And of course, it could be a Java app. It could be an old Java EE app, or maybe a Spring Boot app, or it could be an app that you just built, but it's not ready for the cloud. What we do with the ambassador pattern is, I'm going to misspell this, so don't laugh at me if I misspell it. What we do with the ambassador is it essentially acts like a proxy. So our client, instead of calling over here directly to our legacy app, our client now calls into our ambassador. And our ambassador is essentially a sophisticated or a simple proxy. We'll talk about a variation of the ambassador pattern next, so you can kind of see how this maps out in terms of your own application and how it would work. Okay, so it is at its core a proxy, but what we're doing is this ambassador implementation, which is a proxy, gives you certain things that help you start making this application cloud native. For example, monitoring. Okay, you can also implement things like retries in here. If for some reason your legacy app goes down, right, you have some kind of problem, instead of the client throwing an error, one of the common patterns for cloud native patterns is the ability to retry based on some different types of heuristics. Okay, so we can also put a different kind of adapter here, which we'll talk about in a few minutes. But the core of the ambassador pattern and an ambassador implementation is it gives you the ability to control how you expose that legacy application, and specifically the ability to expose it in a cloud native way so that it can be a little bit more ready for different things like monitoring. Of course, you can add in some observability here, which is critical in cloud native architectures to be able to see all the different pieces working together and see where there might be problems, whether they're errors or scaling problems or whatever. Okay, so this is our first pattern, the ambassador. And so we'll build on this and we'll talk a bit more about how this works. But one thing to note is that the ambassador pattern is specifically targeted more for clients and less for services, right? So it's for end clients, i.e. a user at a web browser, a user on a mobile app, or something like that. And just a quick review, it could be a simple proxy. It gives some cloud native features when you put it in the middle, such as resiliency. And in terms of some implementation details, the proxy, of course, is a separate process. It does not run in the same machine or the same process. Well, when we say machine, of course, for the cloud, it could be a bit ambiguous, but it runs as a separate quote unquote machine. And oftentimes what folks do is they implement the ambassador as a sidecar inside of a Kubernetes pod. Now, I know we haven't talked about Kubernetes and we haven't talked about sidecars, but I'm hoping most of you are familiar with those concepts. Okay, a sidecar is basically a helper application that you can put into a Kubernetes pod. You can then go run in a Kubernetes cluster to get that scaling that we discussed previously. And again, the ambassador gives us things like monitoring, retrying, some resiliency, things like that. Now, where does this fit into the Java universe? So for some Java specific parts about this, whether you're using Spring or Microprofile, you can implement, for example, health checks using standard Spring health checks or Microprofile metrics to give you that additional monitoring and observability. And you can also implement the proxy itself if you want within the application or within a Java application using like something like Spring REST template. Or if you're using Spring version 5, it's called Web Client. It's a new and improved version of the REST template. And if you're using Java EE or Microprofile, there's REST Client 2.0, which you can use to implement the ambassador pattern. Okay, and if we want to have a quick look at how we can write some code to do that, this is kind of what it looks like. I know this is a lot of code, but what this code does is, and this is a Spring Boot example specifically, if you look on the third line, you'll see that it absorbs all of the incoming requests using a /*. And then what we do is we go through and we build up the end URI component, i.e. the legacy app that we're going to proxy, and we go copy the headers into it. And then from there, you can see we construct a REST template, we go make the call, and then we return the result of the proxy call back to the actual client. Okay. Of course, we'll make this slide and the code available so that you can check this out later. Now, I will say that there are different ways to do the ambassador. This is not the most popular way. This gives you a little bit more control as a developer as to what's happening. But if you're just doing a straight ambassador, there's some off-the-shelf things that you can use. And there's something within Kubernetes itself that you can just implement a proxy by doing something like kubectl proxy if you wanted to. Okay, so we've covered a basic pattern. Now let's talk about the anti-corruption pattern. This one is super interesting. And again, it is focused at going and doing things around legacy applications and getting a better sense of how you can do piecemeal or slow migration, or let's say controlled migration of legacy apps to the cloud. Okay, so I'm just going to switch back here to my other view, and we're going to talk about what this actually looks like. And I seem to be having trouble clearing this, so I'm just going to have to undo all that, but that's okay. All right, so now, again, this is the anti-corruption pattern, and it is a stepping stone pattern for moving a legacy application to be cloud native. All right, so let's say that we have other apps which are cloud native. Okay, so we have some teams working in our organization that are building cloud native applications, or maybe it's your own team. You're building cloud native applications, but you still have a legacy app that has some important stuff that you need to be able to do stuff with. Okay, so when we think of the different types of things that we want to implement in our anti-corruption pattern, we're typically talking about services and not end clients. Okay, so the ambassador pattern is more aimed for a web browser, a mobile app that needs to connect to a legacy app that you want to move to the cloud. Now, the anti-corruption pattern is aimed more around services. Okay, so you have different types of services that you want to use for this, right? It could be a service that you've written as a microservice. Okay, and this part is important. It could be maybe you've already started to experiment and are using cloud functions. Oops, I misspelled functions. But cloud functions, or sometimes they're called lambdas, right? Or Amazon lambdas. And it could also be something else, right? Maybe you've already started to build out an event-driven type of application, and all these things need to be able to talk somehow to our legacy app. So what we do in this case is we again have this kind of almost firewall that is our anti-corruption service. Okay, and what we do in this case is that instead of calling directly to our legacy again, our microservice or a cloud function or our event-driven app calls into the app anti-corruption service, and it makes the calls down into our legacy application. Okay, so again, this is a variation, or let's say a more sophisticated version of the ambassador, which has more smarts in it, for lack of a better way of saying it. All right, so the one thing to note again is that this is more aimed around other services consuming a legacy application instead of a end user on a web browser, for example, coming in to our app. Okay, and it is essentially an implementation of a facade and an adapter pattern. It's something that we use to firewall, quote unquote, firewall legacy applications so that we protect the legacy application while at the same time having some cloud native capability that we construct in the anti-corruption service to start taking the first steps to modernizing our legacy app, right? And again, it's useful to migrate large legacy apps to cloud. Everyone has worked on a project where you don't have 5 or 10 features, you may have 50 or 100 plus features inside of it. So how do you go about doing this? Right, so you use this anti-corruption pattern, and inside of this, you can do whatever you need to do to make this more modern and expose it in the appropriate way. For example, let's say you have a legacy app that uses SOAP, right? Everyone remembers SOAP, well, everyone has nightmares about SOAP is maybe a better way to say it. So you've got this application, legacy app that's written in SOAP, and what you can do is you can create this anti-corruption service that has a protocol adapter. So it speaks SOAP down to the legacy app, but on the other side, it presents it as just standard REST or maybe JSON over HTTP, okay? And this is useful when, for example, your legacy APIs are unchangeable for whatever reason, or the person who used to work on this won the lottery and nobody knows how this person wrote this thing 15 years ago or whatever, right? But the basic premise is that it allows you to compartmentalize that legacy application and get a good idea for how you can think about eventually breaking it down, but in the meanwhile, making it fit into the rest of your cloud native architecture in a nice way, okay? So let's talk about some Java specific notes around the anti-corruption pattern. If you remember, right, I know I've said a lot of words there, but if you remember, this is essentially a high level facade or adapter pattern. Okay, so you do have to write some code for this because you're going to be doing something that's very specific and unique to the legacy app that you're essentially putting a facade in front of. And if we're using Spring, we can do this with the REST template again. Now sometimes we call it the newer versions of it are web client in Spring 5.0 if you are on the leading edge of this kind of stuff. But the important thing about this compared to the ambassador is that you do have to do more specific things to expose your legacy app. Again, we gave the example of a legacy app that speaks SOAP as opposed to JSON REST. So then you have to write code, and then you proxy basically from SOAP on the back end to RESTful JSON on the front end, or whatever. Or maybe you're hooking into the event-driven part that we spoke about earlier. And so your event-driven application, you basically read in messages off of something like Amazon SQS, or maybe you're using ActiveMQ, whatever you're using for your messages platform. Maybe you're using Kafka. but you then proxy those calls, and then you would return the results onto in some kind of event-driven platform, whether it's Kafka or SQS or whatever it is. Okay. Similarly, if you're doing microprofile, it's the same type of technique. You just use a different underlying library to do that. Okay. All right. So let's go and talk about a little bit more about this kind of legacy app migration type of idea. All right. Okay. So let's say your app needs to call multiple services. And what we want to do is we want to think about aggregation now. What does that actually mean? All right, so let's go back to our drawing here real quick. So bear with me just a second, and we will get this ready. Let's see where this is. It's in the back here. And let's get rid of all this. I wish there's just a quick way to do this. I had this working earlier, but it like changed the pen color and all that. And I was like, oh, I don't want to do that. So anyways, all right. So gateway aggregation. So let's think of what are the different types of things that will use this. We can have other services, whether they're cloud services or even legacy services for that matter, right? And we also have, let me make this a little bigger actually. No, why it's so small. There we go. That's better, right? So we can have some external service or just a standard client, web browser, mobile app, whatever come in. And what those will do is instead of directly calling different services, right? So we have service A, service B, service C, ... etc. Okay, so we have all these different services underneath the hood. And one thing that we could do, right? So the first kind of thing we might think of as a developer, how would all these different services? Well, we could just do this. We could just go from like a service, or let's say we have a web client, right? It calls all these services directly, right? But the problem is now what we're doing is we're introducing tight coupling from the service into the client code. And if we change one of these services, what happens? We have to change the client, but the client is used by multiple services. Right, so you can see we have a tight coupling problem here, and we want to try to avoid that, right? We want to try to avoid doing that because if we have a one-to-many dependency in terms of the API calls that we're making, that means that whenever service C changes, that means that I would potentially need to test B, A, C, D, et cetera, and we don't want to do that. We want to try to change those things in isolation. Again, if you remember, one of our tenets for doing this cloud-based approach and cloud-native style development is we want adaptability and agility so that we can make changes faster, right? So we don't want to do this. What we want to do instead is we want to use some kind of aggregation gateway. And I apologize for my handwriting. I'm not very good at this, never have been. But I can type really good, so that's great. So instead of the service, an external service or a client calling directly to these services, what we do is we call down into this aggregation gateway, and then the aggregation gateway goes and makes these low-level calls for us. What that means is it gives us a little bit of isolation for our end client and our services at the bottom, so we can go and change this service. And we don't need to go change the client anymore. We basically just go change something in the aggregation gateway that talks to service B so that it knows that we made some kind of change and we need to adapt it in some way. We don't need to change the client. The client still sees what it needs to see or gets the data that it needs to get or pushes the data that it needs to push down into a service, okay? So this is a quick explanation of the gateway aggregation pattern. Right, and the reason why this is important, I think you probably have already figured out why this is so important. But the reason why this is so important is it helps us avoid the dreaded Death Star pattern. Okay, so we talked about having to change the client, you know, if a service has changed, but the real kind of underlying reason is around this avoiding the Death Star pattern. What's the Death Star pattern? right? So this is a graphic that I found. One is from Amazon and one's from Netflix, of different services calling each other. So you have 5 services calling 5 other services, and you can do the math that you're basically making 25 different interconnections between those 5 services that need to call 5 other services. And in a big organization with lots of features and lots of microservices or cloud functions and lambdas, you can imagine how quickly this gets out of control, right? So let's say you have 100 services that potentially can call 100 other services. That means now you have 1,000 different interconnections, and that is bad. That leads to this death star anti-pattern. So that's where this aggregation gateway or gateway aggregation pattern comes into use. It aggregates calls to services, and a client or a service interacts with a gateway rather than directly with another service. Okay, so this can actually be useful in a number of different use cases. I'm gonna go a little off script here and talk about something a little slightly kind of maybe leading edge. We talked about how this can be. Let's see if I can do this properly without clear. Okay, we'll just clear it. Whatever. Probably should have done that to begin with. Okay, let's see if this still works. Okay, hey, it works now. All right. Oh, not that. Okay, so I was working on a project a while ago where I was thinking in terms of cloud functions and lambdas. And if you're familiar with cloud functions or lambdas, right, cloud functions, the idea is that they're supposed to be really, really small and that they are not supposed to technically do more than one thing. So for example, if you're building a set of cloud functions, or let's say you're building a feature around doing something simple, or what we would think of simple in the Java universe as CRUD, right? Create, up, delete. What we would do if we were building this in a Lambda first architecture is we would build 4 different cloud functions, one for create, one for read, one for update, and one for delete. Okay, so now that we have this and our client is here, right? And this, let's just say this is a web browser, right? So our client is directly calling into our backend CRUD application. So it would potentially call this, 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 and this, right? So now we're making 4 different calls to 4 different quote unquote endpoints. And this is something that we need to be aware of, because if we change something that is around the create, then we potentially have to create the client. And anyways, you can see how the death star pattern can come out of this and be problematic. Okay, and Neha actually is asking a good question, which is, wouldn't the aggregator service potentially become a bottleneck? And the answer is absolutely, it can be bottleneck. So we have to make sure we scale this appropriately. And one thing that we could do here is let's back out these changes. Let's continue on this kind of Lambda and cloud functions example, right? So let's say we did put in our gateway aggregator here. And so this talks to essentially not necessarily one endpoint, but one location. And then, you know, we go and that does this. So yes, our gateway aggregator here can become a single point of failure, and it can also be something that is a bottleneck. But the way that we work with this, or we'll see this in a few minutes actually, a future pattern, a way of dealing with this. But what we do is, instead of having a single gateway aggregator, what we do is we put our gateway aggregator into, you guessed it, a Kubernetes cluster, right? So our Kubernetes cluster has multiple gateway aggregators, and then here on the front, we configure appropriate routing / networking, right? We may need to do some, we probably don't need to do stickiness for sessions here, because the session data may be back here. Sorry, those are wrong arrows, right? So our session data is actually kept back here. So that means that this bit here and this bit here can actually be stateless. So stateless is a little bit of a magic word, which we'll hopefully have a little bit of time to talk about later too. But that's an excellent question now. Thanks for asking that. Okay, So let's get back to our slides real quick. All right. And one other thing along with the aggregator being a potential bottleneck is we also have to think, how do we handle failures in downstream, right? So by downstream, I mean, let's undo a bit of this for a second to clear up the clutter. So, and this is a CRUD example. It's not a great example for this specific thing, but I think you'll get the idea. Let's say that for some reason, we're unable to create operations anymore, okay? And we're using our aggregator, again, to go and do this kind of stuff. So yes, we have to be aware of how we handle failures downstream and how that manifests appropriately through the aggregator, okay? So let's get to the Java specific notes. Now, one thing I will say is if you're building out a gateway aggregator, we want to have it performant, right? So someone mentioned, or Neha mentioned, how it can be a bottleneck. So I know that reactive is all the craze right now in the Java universe. Everyone's like reactive this, and I was talking to someone earlier today about like reactive JDBC to make it go faster and use less resources. And absolutely, when you're running in the cloud, which is resource constrained on the actual machine that you're running on, right? So it's horizontal scaling, not vertical scaling. You do have to be aware of the resources, but this is where reactive and asynchronous style programming can come into play. And what you can actually do is you can use, for example, Spring's asynchronous REST template to build out this aggregator so that you have the maximum amount of performance and least amount of overhead as you're building it out. Okay, and of course there's Spring GraphQL, and then there's also the libraries on the microprofile side, specifically SmallRye, allowing you to do GraphQL, which I want to talk about very briefly. I could talk a whole hour about GraphQL, but I don't want to do that right now. I want to get through these patterns and lay the foundation for other things later. Okay, but let's have a look at some code. How would we do a gateway aggregator specifically using asynchronous in Spring Boot? So if we look quickly at this example, you can see what I'm doing is I have completable futures here, and I'm saying go and get and hit 3 different endpoints and return them as futures, package them back up into a single result, and then send that single result back. Okay, so we're doing a couple of different things here. We're using asynchronous type of technology to be able to go and pull this stuff together, as well as using a completable feature, which is, I can't remember which version of Java that came in. I think was that in 9 that they added completable feature? Anyways, doesn't matter. It's and there are other ways to do this. Obviously, you could use just straight reactive extensions. There's Spring Reactive or Reactor. If you're on the microprofile side, of course, there's microprofile reactive, which allows you to do reactive style development also. Okay, so we'll talk a little bit more about this in another specific cloud pattern use case in a few minutes. But let's talk a bit more about backend, or let's talk about a different pattern called backend for front end, or otherwise known as BFF. And the reason why we're interested in this pattern, especially as Java developers who are either building a new application that is cloud native, or we have some legacy that we need to bring along with us, it gives us flexibility and performance. Okay, so we haven't really talked about performance. Performance is its own class of cloud native patterns that we can talk about in some future date, but let's look at the BFF, or backend for front end pattern, and what problem we're specifically trying to solve here, right? And Renat said it was added at Java 8, and you are correct. I thought it was Java 9 for some reason, but you're right. It was added with Java 8. So let's go here and let's clear this out. And I don't like red, so I'm going to change the pen color to something else. Okay, so what does the backend for front end pattern mean? Okay, so let's say you have different front ends, right? So you have web, of course, right? And then you may have mobile, native. Okay.
I don't think you're sharing the.
Oh, you're right. Thank you.
You're welcome.
Okay, there we go. Now I'm sharing. Is that
Yep, we
right?
can see
Can you
it.
see
Yep.
it? Okay, thank you. Okay, and then you may also have mobile web, et cetera, right? So these are all clients of some kind that, and I can't spell for some reason, client. You get the idea. I'm gonna erase that to reduce some clutter. Okay, so you have these different clients, and let's say that you need to call a microservice of some kind. Okay, it's a user service, maybe a profile service, whatever. Okay, so we have microservice, and we may also have some kind of legacy thing that we need to call in the back end. And of course, we could call these things directly if we needed to, right? But the problem with doing this is that now your microservice or your legacy app needs to know how to send data that's appropriate for that platform, or maybe another way of putting it is that it has to create return data of a specific shape and size that is optimized for that platform. Okay, so that could be problematic, and this is where the BFF or backend for front end pattern comes in. So what we do here is we create a BFF for, well, let's call that, since we have web right above it, BFF web, backend for front end, mobile native, okay, et cetera, right? You get the idea. So we have another BFF here for this. Okay, so now what happens is we call into here, looks like my pen changed. Our web calls into, let's get the right pen here, right? Our web client calls into the BFF for web, which can then call here or call here, and similarly for here, into here, etc. Okay, so why would we want to do this? Again, the reason is that we can now return at this layer, we can return the proper shape of the data for web and the proper size of the data that should be returned. And we do not touch this layer down here. Okay, so our app service at the bottom, whether it's a legacy app or a microservice or a cloud function or whatever, it is not touched, but we are able to create these adapters or facade that allows us to have optimized data returned for web clients, native mobile clients, mobile web, whatever. Okay, so when you're thinking about this, or when you're watching me draw this, you were probably thinking, well, this is just a data aggregation type of pattern. And you're right, it can be an implementation of a data aggregation pattern. Okay, so it's not any real magic here. It's just we're applying a more specific use case around a pattern that we already saw. And some might ask at this point, right? Some of you people who are skeptics around all these pattern type of things is, are we doing some premature optimization? The short answer is we might be. Okay, so maybe this is something you introduce a little bit later after you've got like maybe your base prototype up, or maybe you put your beta out and people are using it. And you're like, oh man, I'm gonna make all these changes, but in this microservice or this legacy app, I need to make the specific change to return this data for a web application, and then it starts to grow and grow and grow, and then your microservice is no longer micro, it's more macro. So you're like, let's stop doing this. Let's move this code outside, and maybe we might be able to even repurpose that code for different types of backends where we need to return data from different microservices, but in the same shape and size. Okay, so again, the basic premise is we create a separate backend service for each front end. And because we're doing this facade type of pattern, our data can be shaped and sized for specific needs, and we're not making our microservice any larger than it absolutely needs to be, because we're offloading the work of determining what that data out should look like to something else. So it can be managed individually. And if you remember, one of our core philosophies around design for the cloud is around adaptability, agility, and horizontal scaling, and it fits those tenets. It allows us to have a smaller chunk of code that's isolated from other code so that we're able to make changes to both of those different types of types of things without having to do big bang type of big code releases that require lots of testing and et cetera, et cetera. So what are the benefits? We get improved performance from the front end. We get a little bit more adaptability and agility for our back-end microservices. But the question then becomes, are we duplicating code? We might be. So that's something that we need to be careful of. Another long discussion that we could have is, how do you manage libraries between microservices and implementations of sidecars like this adapter, I'm sorry, this pattern that we're specifically talking about, right? Whether it's the gateway aggregation pattern or the backend for front end pattern, okay? And also, how does this fit into the people side of this? How does the structure of the development team look if you go down this backend for front end route? Who owns this intermediate layer, right? I would say that the people writing the microservices that are eventually hit would own this, but there are people who might disagree and say, well, you probably want someone who's more versed in, right? Maybe the mobile team owns the mobile one, and maybe the web team owns the web BFF, but then they need to have intimate knowledge of the microservice. Okay, it's just something to think about. I don't know if there's a right answer here. I would think it's the actual team building the end service that owns it, but I can see how others would think that the actual front end side of the team should own this. But again, something to think about. Now, I did say that we'll talk about this eventually. This is a good time to talk about REST versus GraphQL. Now, everyone knows what REST is. Everyone's programmed in REST, and we know that there are certain issues with REST. For example, when we work with REST, we're not able to get the exact data we want. The BFF pattern helps to fix this a little bit, right? And also, if we need to get data from different types of resources, let's say we need user profile, and a shopping cart. I don't know, right? Those three things. In a RESTful style architecture, we would need to make 3 calls as opposed to 1 if we were using GraphQL. Now, there are people out there who love GraphQL. I think I saw someone say they love GraphQL, right? And I like GraphQL too. But in terms of a medium to large scale architecture, where you have to be careful with GraphQL, I'm not saying you shouldn't use it. I'm saying that you need to be careful is that once you create this GraphQL layer, and the GraphQL can fit nicely, very nicely, in fact, into a backend for front end, middle layered architecture, what you're doing is you're creating a tight coupling between your transformation layer and the actual services that it accesses underneath. Okay, so that means all that, and I hate using this expression because everyone is, this is a common expression that we use all the time when we're talking to people on the business or our management, and that is, it depends, right? It's so, should I use GraphQL? Well, it depends. Is REST better for this? Well, it depends. It depends on your specific use case. It also depends on how your team is structured and other things like that. Okay, so BFFs, let's talk about Java specific notes. These are the same as previous. Depending on how you're doing your transformation, right? Spring Data is really good for doing this. Spring Data allows you to either reach directly to a data source, or you can kind of proxy into an external REST data source using async REST template, again, to get that reactive, non-blocking style of performant code that you like to see. And of course, if you're using microprofile, you can use something like REST Client Builder and computable futures to be able to do something like this. All right, so let's do a quick time check. We're running a little bit late on time, but I believe this is the last one. So we'll have to stick around for another 10 minutes. Hopefully that's okay. I see Neha nodding yes, so that sounds good. So let's talk about the final pattern for this evening. And again, we've only covered like 5 out of the 35 different patterns, but these are specifically what are known as design and implementation patterns. In the future, if you follow me on Twitter, I'll let you know when I do the next edition or the next version of this course where we talk about data patterns or performance patterns, right, for the cloud, of course. But let's jump into gateway routing pattern. Now, this is also commonly known to some folks as API gateways, and it's already used quite a bit. And in my opinion, it is sometimes misused, right? You know how it is for developers. A lot of times we say, once we bought this hammer, and once we've learned the hammer and we know how to really use the hammer really well, it becomes the hammer that we hit every problem with, right? So that's why I say it can be sometimes misused. It can be that golden hammer approach, which we need to be careful of. But API gateways are essentially a kind of gateway router, something that we discussed already. Okay, so I'm not going to draw this out because in interest of time, but I'll just talk over this diagram. When we think about the way that this looks, right, and I think most people are familiar with API gateways. We have services or clients, and we have some kind of gateway router, and we map URIs like /users, /profile, /cart, and that goes and maps to an underlying microservice or legacy service for that matter, which it allows us to consolidate the endpoints at a certain host rather than having to point to that multiple hosts underneath. And it gives us other things, which most of you are familiar with already. Okay, so let's talk about some of the high level points here, right? We use a gateway for downstream services, right? And those can be all sorts of different types of services. Right? They can be standard microservices or REST services. They could also be other types of third-party services that we route to that we haven't created ourselves. And of course, the gateway routes to that appropriate service. And the gateway also allows us, the gateway router to be specifically, also allows us to do some possible abstractions. Right? And the reason why we want to do this is it helps minimize the change to the client. So if we change something down at the service level, again, we avoid making a change to the client. We just go and change the gateway router. And the coupling between the client and the service can also be reduced. We create the coupling at a higher level and at the higher level of abstraction, which can be useful for, again, that adaptability and agility that we talked about earlier. Okay, but you guessed it, this is yet another facade-based pattern. Okay, so we've seen a lot of facades here, which is fine, right? But again, remember, these facades that we're talking about are not down at the code level. They're more at the kind of module to systems to service level, right? So we have to think about them differently. What are the implications of introducing these patterns up at the systems level as opposed to the code level? We have to think in terms of performance and scalability and resiliency and all those types of things. And yes, Nehal also says that API gateways can also control bombarding the API. Yep, that's something that will flow control, or we call resource protection. That can totally be done, and a gateway router type of service will give us those types of things. But everything, as you know, doesn't come for free. I have a good friend called Neil Ford. He's written a whole bunch of books on software architecture, and he says that software architecture is, there's no silver bullets in software architecture. Everything is a series of trade-offs, right? So the trade-off when we use not just this pattern, but all the patterns that we've talked about so far, is that we might be introducing too much latency. We might be creating a bottleneck. And of course, maybe there's a single point of failure depending on how we've written it. But we showed I drew a quick example of how a lot of these things can be put into their own Kubernetes cluster so that we can scale them, so we don't necessarily have a single point of failure. But of course, the code that we write might be a single point of failure if we don't do things in the right way. Okay. All right. So some Java specific notes. Now, you could write your own gateway router or your own API gateway, but that's not something that we typically do now, right? So we could write them using standard REST clients and REST controller, JAX-RS, etc. But we typically, whether we're using Spring or Microprofile, or for that matter, any technology, not even Java, we typically use the API gateway that our cloud platform provides for us, because it has all the features. And as Neha mentioned, it also has additional features that we don't want to code, like resource protection, controlling flow through the gateway, and controlling the how hard we hit backend services for resiliency, et cetera, et cetera. Okay, and with that, I have some links for further reading on all these different types of things. We can send those out after this presentation, and I am going to stop sharing